Good afternoon, good evening, good morning, whatever time you might be watching this. I just wanted to give you a little run through on how to solve problem 3 and 4 from projectile motion practice, what we were working on class the other day. So, I've set up the problem. You're on your 300-foot cliff. You throw the ball with 15 meters per second of velocity at a 38-degree angle. And I'm going to start all the way back at the beginning of problem 3 and solve for the height. How high will this ball go? So you can see we are on a 300-foot cliff. So our ball will go up a little bit, then it will fall all 300 feet plus a little bit more. And we need to find out what that total height will be, that 300 plus that little bit extra. And to do that, we need to first solve our triangle. We know projectile motion is motion in 2 dimensions. So one dimension is the velocity in the x dimension, the horizontal dimension. The other dimension is the vertical dimension, the velocity of Vyi. So I'm going to take this apart by using my trig functions. So this side is adjacent to the angle that I know. And so adjacent means I need to use cosine of 38 equals adjacent v of x over my hypotenuse, 15. And to solve this, we'll just do a little bit of rearranging. Multiply each side by 15 to cancel out my fraction. 15 times cosine of 38 equals my velocity of x. And that is a nice answer of 11.8, which we will round to 12 meters per second. All right, so I use the cosine function for solving for v of x. To solve for Vyi, initial vertical velocity, that is the opposite side from my angle. So I need to use my sine function. So sine is opposite over a hypotenuse. So sine of 38 equals Vyi over 15. And just like the other one, I will want to multiply by my denominator by my 15 to solve for Vyi. I can put in 15 times sine of 38 into my calculator, and I get this solution to be 9.2 meters per second. So 9.2 meters per second is my initial vertical velocity. Then gravity's going to start acting on that. 12 meters per second is my horizontal velocity, and it will go on that way until it runs into the ground because we are ignoring air resistance. So now to answer part 3, I need to find delta y. That is what I don't know. And to solve for delta y, I have a few different equations I can use. I think there's 3 or 4 of them that have delta y, but only one of them I can use that has everything that I know currently. And that equation is Vyf squared equals Vyi squared plus 2g delta y. I say I know everything in this equation because I am looking at the peak of my path. And at the peak of my path is a special case where my vertical velocity, my Vy, equals 0 meters per second. So it's at that point that the object has stopped going up and it has started coming back down. So because I've chosen that special point is the peak, I do know what my Vyf is. At this point in time, my vertical velocity is 0. So 0 squared is going to be 0. My Vyi, we solved that in our original triangle. That is 9.2 squared, twice gravity, which is always negative 9.8 if we are on Earth, and delta y is the unknown that I need to solve for. So let me do some math. 9.2 squared, type that in my calculator, and that is 84.64. 2 times negative 9.8, that is negative 19.6 delta y. So this 2g delta y, all of that is one term. I just simplified it by multiplying 2 times gravity, which is negative 9.8. So all of this is still considered one term. 0 squared is 0. So I cannot just combine 84.64, take away 19.6, because it is 19.6 delta y. Those things are being multiplied together. I can't move them, separate them yet. So in order for me to solve for delta y, I have to get that variable all by itself. To do this, I'm going to add my 19.6 delta y to both sides. That cancels and makes it go away. And I am left with 84.64 equals 19.6 delta y. And then my last step, divide by 19.6, divide by 19.6, and delta y is 4.3. So from when I threw the ball, it rose 4.3 meters. So my delta y is 4.3. But it's also off of a 300-foot cliff. So my total height is 300 for my cliff, plus that 4.3. So my overall delta y is 304.3 meters. And part 3, question 3, is finished. Question 4 is building off of the same problem. Question 4 is looking at how far horizontally is my ball going to travel. So my delta x is what I don't know. I threw it off a cliff and I want to see how far it made it before it went crashing down to the ground. And I only have one equation for delta x. My only equation for delta x is delta x equals the velocity of x times time. I have currently found the velocity of x all the way up here in my initial triangle. I do know that the velocity of x is 12. I don't know delta x, and I don't know time. So time is unknown. Can I solve for time? Well, yes, I can solve for time. That is, I know a bunch of other pieces to this puzzle, and I can use those pieces to find out how much time it's going to take for that ball to leave my hand, go up, come back down, and run into the ground. And to do this, there's a lot of different steps I could take, a lot of different equations I could choose from. I am going to choose to do this in 2 parts, and part 1 is going to be find my velocity down here, my final Vy at the very end. And I'm going to do that because I don't want to use the quadratic equation. I could use the quadratic equation, but the equation delta y equals Vyi t plus 1/2 gt squared. I know delta y, I know Vyi, I know half of g, but that leaves me with 2 different terms of t, and to solve that equation I need the quadratic equation. And at this point in time, I don't want to do that. So this is doable, but I am going to choose a different route. If you've chosen to do that route, that's great. You're only solving one equation, but you're doing that in a couple steps. I'm going to use 2 different equations. The first equation that I'm going to use is Vyf squared equals Vyi squared plus 2g delta y. And when I solve for this, I am choosing to do this because once I get Vyf, then I can find out my time by looking at my last equation that I will need. And that last equation is G equals VYF minus VYI over T. And I can solve for time and plug that in up here. So this is going to be part 1, solve this equation to get VYF. Then part 2, solve this equation to get time. All right, so here we go. VYF squared, I don't know what that is. That's going to remain my variable. VYF squared, my VYI is 9.2 still. 2 times G, negative 9.8. And now here comes my question. What is my delta Y? I solved and I found delta Y maximum at the peak is 304. But if I'm using my initial Y velocity, I have to go back to my initial conditions. And what is my delta Y here? My delta Y here is negative 300. And so that is because I'm using my initial conditions, not the conditions at the peak. I have to use my initial conditions of negative 300. I'm going to draw a little line there so we know that that was all part 3 and this is part 4. All right, 9.2 squared, we've done that before. 84.64. 2 times negative 9.8 times negative 300. That gives me 5,880. Thank you, my calculator. VYF squared. I add those together. So I can't do anything on this side yet. I still need to simplify this. And I get 5,964.64 equals VYF squared. And my last step is take the square root. And VYF, I didn't give myself enough room, equals 77.2. And we know that should be negative because it's all the way down there at the bottom and it is going down. So my VYF, I'm going to write it down below I'm going to write it somewhere off to the side so you can see. VYF equals negative 77.2 meters per second. And you might say, Mr. Kaufman, why is that negative? Your math showed that it was positive. You can't take the square root of a negative number. And that's exactly why. You can't take the square root of a negative number. So when you take the square of something, it is always going to be positive. If we put negative 77.2 back in this formula and positive 77.2 in this formula, you'll get the exact same answer. Both of those responses are equally true. Negative 77.2 and positive 77.2. That would make my equation work. All right. Final step, solve for time. So, G is negative 9.8. My VYF, negative 77.2. My VYI, that was 9.8, so minus not 9.8, that was 9.2. All that over time. I am going to do a little rearranging. I can combine some terms up there, but I also need to multiply by t to get rid of my fraction. Negative 9.8 t equals negative 77.2 minus 9.2. Then I need to divide by 9.8. Divide by 9.8. And I plug all of this in my calculator. Make sure you do your subtraction first before you hit your division. And that gives me a time of 8.8 seconds. So, using two equations, I know that was 2 steps, but I get a time of 8.8 seconds. Is that my final answer? No, that's not my final answer, but we're almost there. I take my 8.8 seconds of time, plug it in, delta x equals Vx times t, and I can multiply 12 times 8.8, and that gives me a grand total of 105.6 meters. Whew, I made it. Finally. Long time. But I have it finished. Yes, these problems take a while. There's a lot of equations, a lot of different ways. Stick with them, ask questions, and you'll be able to get it. Think about it, draw a picture to help you visualize what all of these parts mean. Keep your negatives and positives straight. Yeah, good luck on your problems today.